Assalamualaikum and hello. I'm going to continue with the drawing of carboxylic acid based on their IUPAC name. So the first thing first, you have to determine the parent chain of your compounds based on the suffix. And the next one, you have to draw the substituents one by one to the left. It's just the simple case as the previous chapters that you've learned how to draw the structure. So let's try example 8. There are few structures of carboxylic acid that you have to draw. I'm going to start with structure A. You got 4-methyl-3-hexanoic acid. So the parent will be 3-hexanoic acid. You have to bring 3 here all together as the parent because 3 here will indicate something. So what is that something? If you see here, I use the spelling H-E-X-E. So not H-E-X-A. The special thing about the name here, the letter E here indicates based on this numbering, which referring to the double bond. So there will be double bond at position carbon number 3. So I'm going to write down a bit additional info here. And the next one, you got hexanoic acid. So the main parent will be carboxylic acid with double bond inside its structure with 6 carbon atoms. So I got 6 carbon atoms here. So I'm going to draw my structure right now for the parent with 6 carbon atoms. Give the numbering for your carbon so that you can check whether your structure is correct or wrong. So this is my first carbon. I'm going to put carboxyl group at this structure. So this carbon automatically attached to double bond O and single bond OH. So this is hexanoic acid, but right now, as I mentioned before, 3-hexenoic acid, which there will be double bond between carbon number 3 and number 4. So that's why I'm going to put double bond here. And the next one, don't forget you have one more thing here, the substituent to the left. You got at position carbon number 4 your methyl group. So I'm going to add up methyl here. So this is the structure for A. Let's go to structure B. Structure B, you have to determine your parent, which will be pentanoic acid. So pentanoic acid is carboxylic acid with 5 carbon atoms. So I'm going to draw in simple drawing based on carbon atoms. So I got 5 carbon atoms and I give the numbering. And after that, at position carbon number 1, I'm going to put my carboxyl group. Automatically this carbon attached to double bond O and single bond OH. And the next one, you have to go to the left for the naming. At position carbon number 3, you got methyl. So I add up methyl here. And the next one, at position carbon number 2, I got chloro. So I put bond attached to Cl. And next, you have to fill in all carbon atoms. Make sure each of them got 4 bonds. So let's start with carbon number 1. It's enough. Next, carbon number 2, I got one more attached to hydrogen. And the next one, carbon number 3, attached to 1 hydrogen. Carbon number 4, attached to 2 hydrogen atoms. And carbon number 5, I got 3 hydrogen atoms. So I can draw like that as well. So this is the structure for B. Next one, let's go to structure C. I have 3-amino-5-isopropyl benzoic acid. So my parent will be benzoic acid. So I hope all of you can understand and remember how to draw the structure for benzoic acid. It will be benzene ring attached directly to carboxyl group. So I'm going to draw like this. Automatically this carbon in the ring will be first carbon. So this is first carbon, second, third, fourth, fifth and sixth. And after that, to the left of your naming, you got at position carbon number 5, you have isopropyl. So I'm going to put isopropyl here. Make sure you draw the bond first at position carbon number 5 and then kaki ayam to indicate the isopropyl structure. And after that, I got at position carbon number 3, you have amino. So amino, please remember, bond first attached to NH2. So this is structure C. Let's go to structure D. I have this naming quite long, but don't worry, usually the parent will be at the end. But right now, where I'm going to start, I'm going to take a look. Okay, this is SC and you got carboxylic acid. In front of it, in 2 hex and cyclo. So my parent will be cyclohex 2 in carboxylic acid. This is what will be your parent. So the parent will be a ring with 6 carbon atoms because hex, and then you got carboxyl group attached to the ring directly. So I'm going to write down a bit. So at position carbon number 1, you have COOH group, and the next one, this is the ring for 6 carbon atoms. And after that, at position carbon number 2 here, if you see carefully, this is the naming end with E and E. So it means that at position between carbon 2 and 3, you got double bond. So make sure between 2 and 3, you got double bond. So how I'm going to draw this one? I'm going to draw my ring first. So I'm going to draw 6 carbon atoms in the ring. So this is my structure. Give the numbering. You got 6 of them. And after that, between carbon 2 and 3, you have double bond. So I'm going to draw the double bond here. And next, you have carboxylic acid here, which is your carboxyl group attached directly to first carbon. So put the bond COOH. Make sure carboxyl group, your carbon bonded to the carbon in the ring. And after that, let's continue with the substituents. At carbon number 5, you have nitro. So I'm going to put the bond first, attached to nitrogen with 2 oxygen atoms. This is NO2 for nitro. And the next one, you have at position carbon number 6, you have bromo. Put the bond first, and after that, attach to Br. So this is structure D. So please take a look at the naming carefully. Let's go to structure E. So structure E, the same case here, I'm going to determine my parent. So quite long for my parent, which will be cyclohex 4-in-1,3-dicarboxylic acid. So let's go one by one. So at position between carbon number 4 and 5, you have in, indicating the double bond. So this will be double bond between carbon 4 and, so I'm going to put like that, double bond. And after that, I got this one, 1,3-dicarboxylic acid, means that you have carboxyl group COOH, 2 of them at position carbon number 1 and number 3. And all of these will be in the ring with 6 carbon atoms because cyclohex. So I'm going to draw my ring first, 6 of them, 1, 2, 3, 4, 5, 6. And after that, give the numbering. And at position carbon number 1 and 3, I have carboxyl group. So I have to draw the bond first. 1 bond attached to carbon number 1, COOH, and carbon number 3, COOH. Next one, between carbon number 4 and number 5, I have double bond. So I put double bond here. So settle for my parent. Let's continue to the left. I have my substituent at position carbon number 2 is nitro. Put the bond attached to NO2. And at position carbon number 5, I have ethyl. Put the bond and then attach to ethyl. So you got CH2, CH3. This is CH2, this is CH3. Or if you want to write it down in terms of formula, you can write it down as CH2, CH3. So either way is acceptable. So this is the drawing for structure E. Let's go to the next structure. This will be the last one. I have cis-2-ethyl 3-methyl 2-butene dioic acid. So how to draw this one? I know you can see the term cis here, but don't be afraid. We are going to draw the normal structure first. So let's continue with the normal structure without cis. So I'm going to draw based on the rule that I've used before. Determine the parent first. So the parent will be 2-butene dioic acid. So what does it mean by here? You got 4 carbons for your alkene. If you see here, you got in. So this is for double bond. At position carbon number 2, you got double bond. And after that, dioic acid here means that you have 2 COOH group, okay? Your carboxyl groups. It will be at the end of each chain for these 2 carboxyl groups. So I'm going to draw 2-butene first. So let's continue with 4 carbon atoms. So this is the normal structure. And then give the numbering so that you can see it very clear. And then between position carbon number 2 and 3, you have double bond. So 2-butene. So you got double bond here. And after that, each end, carbon 1 and carbon 4, you got dioic acid, indicating 2 carboxyl group. I'm going to put this carbon attached directly to double bond O, OH. Same goes for carbon number 4. So carbon number 1, double bond, and then OH. And carbon number 4, double bond, and then OH. So this is the parent. And after that, I have 3-methyl. So at position carbon number 3, I have methyl. This is CH3. And after that, at position carbon number 2, I have ethyl. So this will be CH2, CH3. So now, this is the normal structure. How you want to draw in cis form. Let's take a look whether you have restricted carbon-carbon double bond. So if you see here, you got one, which is positioned between carbon number 2 and 3. This is your restricted carbon-carbon double bond. And after that, you have to check. At position carbon number 2, you got different group or not. Same goes for position carbon number 3 here. You got different group or not. So let's continue with carbon number 2 first. So you got carboxyl, one group, and you got ethyl, one group. So still complete the requirement. Let's go to carbon number 3. You got different group or not? So carbon number 3, you got carboxyl here, one group, and you got CH3, one group. So between CH3 and carboxyl, different for carbon number 3. Between carboxyl and ethyl, different for carbon number 2. So it can do cis. But right now, in order for you to show cis, you have to determine carbon 2 and 3 must share one same group, which is, in this case, is carboxyl group. So I'm going to put my carboxyl at the same side between carbon 2 and carbon 3. So draw your horizontal V shape right now. So carefully, horizontal V shape like this. So this one will be carbon number 2, this one will be carbon number 3. So first carbon will be here. So I'm going to put this is as first carbon. So your first carbon attached to double bond O, single bond OH. So this is carboxyl group. And the next one, carbon number 2, you got ethyl here. So I'm going to draw ethyl here. So this is CH2, CH3. Okay, settle for left side for carbon number 2. Now continue with carbon number 3. I'm going to show cis form based on carboxyl group. So I got one here. So another one at carbon number 4 will be here to show same side for cis. So this is carbon number 4. Carbon number 4 attached to double bond O and then OH. And carbon number 3 here attached to CH3. So I got CH3. So where is the most important thing in this structure? I want you to draw the normal one first. And then after that, when you convert, the final drawing must be in horizontal V shape like this. So what I'm going to see here is this one, horizontal V shape. So only this bond. The rest of them, if you want to draw in skeletal form, it's fine. Or if you want to draw just like this one with chemical formula, it is also fine. So this is how you draw the structure for carboxylic acid. I hope all of you understand carefully about how to determine the parent first, because most of your parent sometimes got a long name. So you have to take a look carefully. So that's it for this video. I'm going to continue with the next one in the next video. Thanks for watching. Bye.